Hello and welcome. This is Columbia Basin Research's second video in a multi-part series on using Program Roster. Program Roster is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences. Program Roster models the life cycle of Pacific salmonids from the initiation of the juvenile migration as smolts to the end of the spawning migration as adults. This model jointly analyzes juvenile and adult pit tag data, including those transported as juveniles and returning as adults. Multiple performance measures useful in monitoring the juvenile and adult migrations and assessing recovery efforts are produced by the model, including estimates of juvenile in-river survival, ocean survival, adult in-river survival, transportation effects, for example TI and D, SAR, and adult age composition. In this second video, I'm going to show you how to define your model, set up your parameters, and run your estimation routines. Future videos will offer various hints and tips on getting the most out of the program and refining your routines. Alright, so in our previous video, we loaded in our data. Once the data set has been loaded, click on the Estimation tab in the program interface. The Estimation tab has three sections: Model Definition, Parameters Set by the User, and Estimate. The message window remains at the bottom of the program interface. The first step of the estimation process is defining and loading the model on the Estimation tab. Roster provides a default model based on statistics compiled from the dataset and the adult site to which transportation effects will be calculated. Alternatively, the expert user may modify the default model by saving the model file generated by Roster and then editing it and loading the new model file. The selected model is loaded by clicking on the Load button. The model used in Roster is a statistical likelihood that is fit to the data to estimate juvenile ocean and adult survival probabilities of transported and non-transported fish, juvenile and adult detection and censoring probabilities, and transportation parameters. The most general or full statistical model estimates separate values for each of these parameters, distinguishing between transported and non-transported fish and among transport groups in classifying adult parameters. It is often both difficult and unnecessary to treat all parameters as unique. Instead, it may be sufficient to equate certain model parameters. In particular, it may be reasonable to equate adult parameters among all transported fish, or perhaps for all fish, regardless of juvenile migration method, transport or non-transport. Program Roster is designed to run with as little input from the user as possible. A default statistical model is configured automatically by the program based on observed statistics from the data. This model will be a simplified version of the full model, tailored to the dataset. The default model generated by Roster estimates unique upriver adult survival parameters for fish transported as juveniles and those not transported as juveniles until the site selected in the Extent of Transportation Effects window. The default model also estimates unique adult detection and censoring parameters for transported and non-transported fish at all adult detection sites up to the site identified as the Extent of Transportation Effects. Additionally, the default model identifies which parameters to estimate and sets initial values for those parameters to be used by the estimation routine. In many cases, the default model will be sufficient for complete data analysis, in which case it is not necessary to save or edit a model definition. To use the default model, make sure that the Default Model button is clicked on the Estimation tab and click on the Load button. Alternatively, the default model may be used as a starting point for the user to find models. If the user chooses to modify the default model, then it is necessary to save and edit the model definition file. The model definition file is used by Roster to define changes in the structure of the statistical model compared to the full model described above. The statistical model used by Roster is not itself shown in the model file. In general, the changes defined in the model file consist of: number 1, equating parameters; number 2, fixing parameters to the particular number; or number 3, specifying the initial values, seeds, to be used in fitting the model. The model file also specifies the number of juvenile and adult detection sites and adult age classes as entered on the Data tab of the Roster interface, as well as the site identified as the extent of the transportation effects on the Estimation tab. User-specified values for untagged transport parameters and barge transport survival are also listed in the model definition file. After the default model is selected and loaded, it can be saved in a model definition file and edited. To save a copy of the model definition file for the default model, select Save Model Definition from the File menu. The file can then be edited using an XML editor or any text editor. The user may edit the model file by changing the parameters that are equated, fixing parameters so that they are not estimated, removing parameters from the list of fixed parameters so that they are not estimated, or setting initial values. We'll go into more guidance on fitting models in future videos in this series. Once the model definition has been edited and saved, it is available for use by the program. Click the button next to Model Definition File in the Model Definition section and select the file by clicking on the ... button. After selecting the desired model definition file, click on the Load button to load the model. With the model loaded, two more reports are available under the Reports menu. The Parameters report shows initial values for estimation using the loaded model. The parameter indices report shows the structure of the model. The second section of the estimation tab allows the user to modify values of parameters that are always fixed in raster rather than estimated. These fixed parameters do not affect the model fit or estimates of the model parameters, but they are used in calculating estimates for certain performance measures. The first set of fixed parameters pertains to estimating transportation effect measures for untagged fish under the heading Untagged Transport. The parameters to be set are the dam-specific transportation probabilities for untagged fish, representing the portion of the collected untagged fish that are transported from each juvenile detection site, i.e. dam. The default values are 100% transported at transport dams, and 0 at other juvenile sites. The default variance is 0 for each parameter. The user may enter different values and positive variances if available. The second parameter set by the user is the barge transport survival, or the survival probability of the transported fish on the barge or truck during transportation. This parameter is used to estimate various measures of D, differential mortality. The default value of barge transport survival is 98%, with a variance of 0. The user may alter the survival parameter or enter a positive variance for the survival parameter if available. When the user loads the default model or a model definition file, the loaded model should specify values for the untagged transport parameters and the barge transport survival. When the model is loaded, the parameters set by the user section of the raster interface will show the values specified in the loaded model. The user may change the values of the untagged transport parameters and the barge transport survival and their variances by highlighting the appropriate box in the raster interface and editing the values. Clicking the cancel button will revert the parameters to their previously saved values, while clicking the defaults button will revert the parameters to their default values. The user must tell raster to apply the values from the interface if they have been changed, either by clicking the apply button or by clicking estimate parameters and selecting save from the dialog box that opens. Either action will tell raster to calculate performance measures using the new values for the untagged transport parameters and barge survival, but without overwriting the values saved in the model definition file. In order to save a version of the model definition file with the new values of the user set parameters, the user must first click apply and then select save model definition under the file menu. The final step of the estimation process is to run the estimation routine. Program status and any error messages are displayed in the message window at the bottom of the program interface. The function value reported in the message window is the negative log likelihood value for the current iteration. This value depends on the parameter values being used and is minimized by the estimation routine. An extremely large function value such as 1.8 times 10 to the 308th power indicate an error in the model file or an estimation routine. It is important that the user get into the habit of looking for this result. Any estimated parameters that result in this outcome will most likely be false. A final message of success or failure of the estimation routine is shown in the message window. If the estimation routine fails to converge, then an error message appears and it is necessary to reload the model in order to examine reports or attempt to rerun the estimation routine. Several types of reports are generated by raster throughout the data loading and estimation process and are available under the reports menu. Once the data set is loaded, the data summary and sufficient statistics reports are generated. After the model is loaded, the parameters report and parameter indices report are available. After the estimation routine has been successfully run, the estimation results report and covariance matrix report are also available, as well as text files containing estimates of the model parameters and performance measures. After the data set has been successfully loaded, a data summary is available by selecting Data Summary from the Reports menu. The data summary provides a useful report of basic statistics including size of the release group, number of detections at each juvenile site, number of detections at each adult site classified by juvenile transport group and adult age class, number of fish transported at each juvenile site, and number censored at each juvenile site and at each adult site classified by juvenile transport group and adult age class. The data summary report gives a quick, useful overview of the data set. A more detailed and technical version of the data summary report, the sufficient statistics report, is useful mostly for the expert user fitting a model other than the default model. The sufficient statistics report shows the statistics based on the data that the statistical model actually uses. The following table describes the nature of the sufficient statistics in this report. The parameters report is available in a preliminary version after the model has been loaded and in a completed version after successfully running the estimation routine. Before running the estimation routine, the preliminary report shows the method of moments estimates for each parameter, with all adult parameters showing the same estimate across transport and non-transport groups. The method of moments, or MOM estimate, is usually a good educated guess as the starting value for the parameter for the estimation routine. The first time the estimation routine is run using the default model, these MOM estimates are used as initial values or seeds. The parameters report also indicates which parameters are fixed rather than estimated, and the value at which they are fixed. If the default model does not run successfully, the parameters report may indicate where the problem is. For example, if the MOM estimate for the parameters is 0 or infinity, then the default model will not run properly, and the user will need to modify the model file. After the estimation routine has successfully completed, the parameters report shows 3 values for each parameter: the MOM estimate, the seed initial value actually used, and the final maximum likelihood estimate (MLE) found by the estimation routine. Unless the user tells the roster otherwise, the MOM estimate and the seed will be equal. In many cases, the MOM estimate and the MLE will be equal as well. Certain roster features allow the user to alter the initial values used in running the model. In these cases, the seeds shown in the parameters report will be different from the MOM estimates. It may still be the case that the MLE is equal or nearly equal to the MOM estimate for each parameter. Running the estimation routine many times with different starting values is a good way to check that the estimation routine has correctly found the true maximum likelihood estimates. The parameter indices report is available after the model is loaded. It indicates the structure of the loaded model by showing which parameters are estimated and which parameters are fixed, not estimated. Estimated parameters show a number in the index column. Equated parameters share a common index. Upon successful completion of the estimation process, the program will generate and display an estimation results report, which includes estimates of the parameters and performance measures. This report can also be shown by selecting Estimation Results under the Reports menu. Performance measures that exclude jacks are shown at the bottom of the report. Model parameters and performance measures will be examined further in a future video in this series. The Covariance matrix report gives the variance-covariance matrix estimated for the model parameters by roster. Each entry in the matrix is the covariance between two parameter estimates. Only parameters that are actually estimated, not fixed, are included in the matrix. The Covariance matrix report may be saved and then imported into other software for examination. The parameter estimates and performance measures reports list the estimates and standard errors of all possible model parameters and performance measures, respectively, in simple text files that may be saved and imported into other software. They are available under the Reports menu. Program Roster includes several tools designed to help the user find the best model fit. In general, the initial values calculated by roster will be very close, if not equal, to the actual MLEs. However, the methods of moment estimators used by roster as initial values will not always provide the best model fit, and in some cases they will not be the best initial values. Also, it is possible that the estimation routine misses the best model fit because of the step size used or because it ended too soon. These problems can be detected and avoided using roster's diagnostic tools. Program Roster uses the optimization routine Fletch to find the MLEs. The precision, step size, and maximum number of iterations used by Fletch can be changed under the Configure menu. In general, a smaller precision makes the stopping criterion more stringent for the optimization routine. The step size indicates how large a change in each parameter is considered between iterations. If the step size is too large, the optimizer may step over the true MLE and never find it. If the step size is too small, the optimizer may not be able to leave the initial values seeds even when the true MLE is elsewhere. Thus, it is wise to rerun the estimation routine several times, varying the step size with a fairly small precision. The default value for precision and step size are both 1 times 10 to the power of -6. In addition to changing the Fletch parameters, the user may use alternative seeds initial values to start the optimization. This can be useful if different seeds lead to different final estimates. Then the optimizer may be missing the correct MLE. Parameters report is useful for keeping track of the seeds used and the final estimates found when using these tools. Under the Diagnostics menu is the Parameter Seeds option, which allows the user to introduce random noise into the default MOM seeds. To introduce random noise into the parameter seed, select Introduce Random Noise to Initial Seeds. Select either Proportional, the default, or Absolute type, and then enter the amount of noise desired. If parameters are very close to boundaries, for example 0 or 1, then a large amount of noise may lead to sets of initial parameter values that are not viable. In these cases, running the estimation routine will lead to an error message. Rerunning the estimation routine may produce a set of random initial values that are viable, or it may be necessary to reduce the amount of random noise introduced in the seeds. In order to turn off the random noise in the seeds, unselect Introduce Random Noise to the initial seeds and click OK. Alternatively, the user may specify seeds in the model file. This has been lesson 2 on using Program Roster, in which we sorted out how to define your model, set up your parameters, and run your estimation routines. Future videos will offer various hints and tips on getting the most out of the program and refining your routines. We hope that this video helps you get the most out of Program Roster. Again, if you have any questions or comments in regard to Program Roster, you can find the user manual at cbr.washington.edu/analysis/apps/roster and fill out our survey there as previously detailed. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck with your analyses, and thank you.